Okay, so what we're going to do here is we're going to start off with how we graph a trig function. When we start talking about graphing a trig function, we're really taking our unit circle and we're going to call this the x-axis and we're going to call this the y-axis, where y is equal to sine of x. Here, x, I pick a point here. I know this point here is 1, 0 at 0 degrees, 0 radians. This x is really my angle. So you can call this x, but I think people get mostly confused because it's xy, and here I have xy. If it helps, we can think of this as our angle theta, okay? But we're going to call it the x-axis. So if I want to plot this first point, well, it's 0 and I'm going to only use graphing in radians. Anybody who's not really familiar with radians, we're going to get really familiar very quickly. We start here with 0 radians, and at 0 radians, my sine value is always equal to the y value. I have this point 0, 0. We always start here. This is 0 degrees or 0 radians, right? This point right here. That makes sense?
Yes.
Okay, good. And then at that point, remember I have this unit circle. We call it a unit circle because the radius is 1. If I go from here to here, that is the radius of this circle. And I'm saying this is a unit circle, so it has to be 1. And then my y value is 0 because it's on the x-axis. I haven't gone up off of the x-axis. I have this point 1, 0 that's on this circle. But we have our x value, which is my first value here, is the same as the cosine of theta. And my y value, we say, is the same as the sine of theta, right? So that's why this is really confusing when I put this x here, because it's really theta. So when I look at, and if I'm graphing the sine, I'm actually looking at what is the sine here. Let me make it, maybe I should make a chart over here. So let's call this x, and let's call this sine of x. So when x is 0, and this is in radians, okay? So when x is 0, I want to look here, and I know that my y is 0 because my y value here is the same as the sine. You with me now?
Yes.
Okay, perfect. So I'm going to make this a little bit easy on us because there's a lot of points in between, right? But the next point I want to graph, because it's another really pretty easy point, is, well, this is x is 0 and y is 1, right?
Yes.
And this also is going to be 90 degrees, but we're going to call it pi over 2 because, again, we're only working in radians. So I'm going to place here pi over 2. And at pi over 2, my y value, which is the sine, is equal to 1. Make sense?
Yes.
Oh, good. All right, then we're going to be fine. Okay, so I have pi over 2, 1. The next point is going to be, so we started 0. At the top is half of pi, and over at the all the way to the left is pi. And
Right.
down here, my radians are 3 pi over 2. And then also this becomes 2 pi and so on. Okay. So here again, if I want to know, if I take pi, well, this point right here, x is -1, y is 0, right?
Yes.
So at pi, my sine, which is my y value, is 0. And then we'll go take 3 pi over 2. And at 3 pi over 2, x is 0, y is -1. I'm looking for my y value because it's sine. So I get -1. And then the last point I'll pick is 2 pi, which is the same as 0. And at 2 pi, it's back to the y value is 0. Okay? So now I'm going to take all these values and I'm going to plot it on this graph. So here's pi, here's 3 pi over 2, and here's 2 pi. And so those are my angles, and this is my x value. So pi over 2, I have 1. At pi, I have 0. At 3 pi over 2, I have -1. And at 2 pi, I'm back to 0. And of course, I have all these points in the middle, right? But I can get a good sketch of a graph with just this information. So I can just connect the dots now. And it's going to look something like that, okay? But this just keeps going because I can still go back around the circle as many times as I want, right? I can continue around that circle. And if I go this direction, I'm going positive. And if I go this direction, I'm going negative. So if I want negative pi over 2, that's the same as 3 pi over 2 because I'm going negative half of a pi. So I can say negative pi over 2. Well, it's the y value is -1. And so I can continue. And the truth is this continues on. It continues on infinitely in both directions. That's basically how we're using this circle to make a graph of the sine. This is what our sine function looks like, and now you saw how we create it. There's some properties of a sine function. So the domain is the set of all real numbers, because as I said before, this continues in both directions forever, okay? Just keeps doing this thing. The range, so that's the y values, consist of all real numbers between -1 and 1. If I want to know what the sine of a function is, the answer to the sine of any angle is between -1 and 1. Okay, and we can see that from our graph. The sine function is odd. We didn't talk a lot about odd and even functions, I don't believe, but odd functions always reflect around the origin. So what that means is, if I take this graph, and if you want, you could draw a picture of this real quick. And if you take this graph and you draw a picture and you turn it completely upside down, it should look exactly the same. Okay, it does, right? That's because it reflects around the origin. So anytime you have a reflection of a graph around the origin, just flip it 180 degrees and it looks the same. You have the same graph, okay? The sine function is periodic. What it means is it goes on, but it has a period of 2 pi. So if we start here and we continue around this graph to 2 pi, notice it's going to start and it's going to look exactly the same again. So if I start here, notice it looks exactly the same. And it would continue like that forever. And we have this thing, and it's called the period, and the period is 2 pi. It's one cycle. Okay, so we have one cycle. The green one is 2 pi. The red one is 2 pi. All of them are going to be 2 pi. Okay, so that's the period for the sine function.
Mhm.